We need to measure intervals of time which are much shorter than a day. Clocks and watches are the most common time measuring devices used by us. All the clocks and watches use the principle of periodic motion for measuring time. You have learned in previous class that a motion which repeats itself at regular interval of time is called periodic motion, right? One of the most common devices which show periodic motion is the simple pendulum. A simple pendulum is a small sized metallic bob which is suspended by a light string from a fixed point. Okay, it cannot be stretched and is of a definite length. This thread allows the bob to oscillate freely without any kind of obstruction or friction. The pendulum bob moves to and fro following the same path, and this to and fro motion of the pendulum is called the oscillatory motion. The motion of the pendulum was first studied by Galileo. Okay, it is being believed that once Galileo was sitting in a church at Pisa, that is in Italy. There he saw a chandelier hanging from the ceiling with a long chain swinging slowly. There was no watch or clock at that time to measure time. So Galileo timed the oscillations by counting the beats of his pulse. Okay. On careful observation, he found that while the oscillations of the chandelier gradually slowed down, the time taken by one oscillation still remained the same. In other words, a pendulum of a given length always takes the same time to complete one oscillation. This observation led to the development of pendulum clocks. Okay, let's see some terms related to simple pendulum. The first one is length of the pendulum. So the length of the string from the point of suspension to the center of the bob is called the length of the pendulum. So this is what is the point of suspension, and to the center of the bob is what is the length of the simple pendulum, and it is denoted by L. Okay, so right from the point of suspension to the center of the bob, it is the length of the simple pendulum. Okay, the next one is mean position of the bob. Okay, the position of the bob when it is at rest. So when it is being suspended, the bob is at position B, and this position at B is called as the mean position of the bob. Okay, so just remember that the position of bob when it is at rest. So at B, the bob is at rest, and that is known as the mean position of the bob. The third one is extreme positions of the bob. Okay, the positions where the bob is at the maximum distance from the mean position. Now if you see here, at B it is at rest, and when it oscillates, it moves to the extreme positions, to its maximum distance. So here this side A is the maximum distance, and here this side C is the maximum distance. So in this figure, A and C are the extreme position. The next term is oscillation of the pendulum. Okay, so one complete to and fro motion of the bob about its mean position is called an oscillation of the pendulum. Okay, now when the bob moves from the mean position, that is from B to A, and then from A to C, and when it comes back again to B, that is called as one oscillation. In other words, when the bob moves from one extreme position A to the other extreme position C and come back to its mean position B, it is called as one oscillation. I repeat the definition: one complete to and fro motion of the bob about its mean position is called an oscillation of the pendulum. Okay, we have time period, the next term. So time period of the pendulum is the time taken by the bob of a pendulum to complete one oscillation. Okay, that means the total time covered, okay, or taken to complete this one oscillation is called as the time period. Okay, the next term is the amplitude of simple pendulum. Now it is defined as the maximum distance travelled by the pendulum from its mean position to the extreme position of the pendulum. Now B is the mean position and it is travelling to the extreme position, that is the maximum position, that is A. So BA is the amplitude here. Further it is again going back from B to C, so that is also the amplitude of simple pendulum. So in short, the displacement BA or BC is called the amplitude of simple pendulum, which is the distance travelled by the pendulum from mean position to the extreme position of the pendulum. Okay, the last term is frequency of the pendulum. The number of oscillations made by the pendulum in 1 second, okay, is called its frequency. Now we know what is oscillation, right? So the number of oscillations made by the pendulum in 1 second is called the frequency of the pendulum. So frequency is being denoted by 1 by time period. We know what is time period, right? The time taken by the bob of a pendulum to complete one oscillation. So once you get the frequency, you will come to know the time period. If you have the time period, definitely you will come to the reciprocal of the time period will give you the frequency. Okay children, here is a simple activity to determine or say to measure the time period of a simple pendulum. Things needed here is a metal ball or say a metal bob, a string of length 1 meter, an iron stand and a stopwatch. Let's see the method. Set up a simple pendulum with a string or thread of length nearby 1 meter, carrying the bob at lower end and tied at its upper end from a rigid support, say iron stand. Now switch off the nearby fans, okay, because we need to let the bob rest at its mean position. Okay, now mark the position of the bob on the floor below it, so that will be your mean position. Now to set the pendulum in motion, hold the bob gently and move it slightly to one side. Now release the bob from its displaced position gently. Do not push the bob while releasing it. Okay, ensure that the bob does not spin on its axis while oscillating. So it should only oscillate. It should not spin about it or on its axis, right? Start the stopwatch when the bob is at one of the extreme position. Keep on counting the number of oscillations made by the pendulum bob. Measure the time which pendulum bob takes to make 20 complete oscillations. repeat the same activity by pulling the bob to a greater or a lesser distance from the mean position by changing bob and then by changing the length of the pendulum. What do you observe here? Okay, so the time period of the pendulum remains the same until the length of the pendulum is changed. Okay, so what we conclude here, that the time period of pendulum does not depend upon displacement of pendulum from its mean position and mass of the bob, but the time period of pendulum depends upon the length of the simple pendulum. So children make a point that the time period of pendulum does not depend on the mass of the bob or the distance displacement of pendulum from its mean position, but it depends only on the length of the simple pendulum. Okay, so let's talk about the unit of time. So we know the SI unit, standard unit of time, is second. So 60 seconds is equal to 1 minute, 60 minutes is equal to 1 hour, 24 hours is a day, and 7 days is a week, then 4 weeks plus more 2-3 days is what is your month. So that is, you can say 30 days is equal to 1 month. Then you have 12 months is equal to a year. 100 years is equal to your 1 century, and 10 centuries, that is 1000 years, is equal to a 1